The conceptual roots of artificial intelligence, AI, trace back to the 1940s, when pioneers such as Alan Turing and John von Neumann began exploring whether machines could mimic human thought. In 1950, Turing proposed what is now known as the Turing test, a criterion to evaluate a machine's ability to exhibit intelligent behavior indistinguishable from that of a human. During this era, the groundwork for digital computers was laid, providing the hardware substrate necessary for later AI research. AI emerged as a distinct academic discipline at the Dartmouth Summer Research Project on Artificial Intelligence in 1956. Led by John McCarthy, who coined the term artificial intelligence, alongside Marvin Minsky, Nathaniel Rochester, and Claude Shannon, this workshop set the research agenda for the field, emphasizing symbolic reasoning and problem solving. Early successes included Alan Newell and Herbert A. Simon's Logic Theorist, capable of proving mathematical theorems, and Joseph Weizenbaum's ELIZA, an early natural language processing program that simulated conversation. Throughout the 1970s and early 1980s, AI research was dominated by symbolic approaches and expert systems, computer programs designed to emulate the decision-making ability of human experts. Notable systems included Mycin, which diagnosed bacterial infections, and Dendrol, which assisted in organic chemical analysis. These successes spurred commercial interest and investment in AI, particularly in sectors such as medicine and finance. However, symbolic AI relied heavily on handcrafted rules and struggled with real-world complexity and the combinatorial explosion of possible rule interactions. By the mid-1980s, the limitations of expert systems became apparent. They were brittle, difficult to maintain, and expensive to develop. This led to reduced funding and two major AI winters, during which progress slowed and optimism waned. Yet these downturns were followed by resurgences. In the 1990s, the rise of statistical machine learning methods, leveraging growing computational power and large datasets, enabled new approaches such as decision trees, support vector machines, and Bayesian networks. By the turn of the millennium, AI research had shifted decisively toward data-driven techniques. Landmark achievements included IBM's Deep Blue defeating world chess champion Garry Kasparov in 1997, and the advent of large-scale data processing and improved algorithms. Internet-scale data repositories fueled breakthroughs in computer vision, speech recognition, and natural language processing. This period saw the emergence of companies leveraging AI for search engines, recommendation systems, and fraud detection. The 2010s witnessed the deep learning revolution, characterized by neural networks, with many layers achieving unprecedented performance across a range of tasks. In 2012, a convolutional neural network dramatically improved image classification accuracy, reigniting interest in neural approaches. Subsequently, deep learning powered breakthroughs in machine translation, speech synthesis, and game playing, culminating in Google DeepMind's AlphaGo defeating Go champion Lee Sedol in 2016. Cloud computing platforms democratized access to powerful GPUs, further accelerating research and deployment of AI. Starting around 2020, AI entered the era of foundation models, large-scale pre-trained neural networks fine-tuned for multiple downstream tasks. OpenAI's GPT series exemplifies this trend. GPT-3, released in 2020, demonstrated the power of few-shot learning in natural language processing. In 2023, GPT-4 introduced multimodal capabilities, handling text and images, and further improving reasoning and creativity. Meanwhile, other organizations launched models like Google's PaLM and Meta's Llama, driving competition and innovation in both open source and commercial AI. Generative AI capabilities expanded rapidly, spawning tools for text, image, audio, and code generation. Systems such as DALL-E, Stable Diffusion, and Midjourney enabled users to create high-quality imagery from textual descriptions, while variants of GPT facilitated conversational agents, automated content generation, and code assistance. The year 2024 marked extraordinary progress in AI both in foundational research and practical applications. At the start of the year, Google introduced ImageFX and MusicFX, generative tools for creating images and audio clips from text prompts, demonstrating the deep integration of AI into creative workflows. Concurrently, AI models achieved breakthroughs in scientific domains. Advanced systems from OpenAI and Google outperformed PhD-level virologists in laboratory troubleshooting tasks, raising both excitement for accelerated research and concerns about biosecurity. Generative AI further permeated everyday software. AI-driven features appeared in search engines, office productivity suites, and design tools, shifting the focus from showcasing raw model capabilities to delivering practical value. Energy efficiency and cost concerns prompted research into sustainable AI, with organizations exploring specialized hardware and low-energy algorithms. In specialized domains, Google DeepMind's GenCast leveraged decades of meteorological data to deliver faster and more accurate weather forecasts compared to traditional models. Meanwhile, the State of AI Report 2024 highlighted that 78% of surveyed organizations regularly use AI in at least one business function, underscoring AI's maturation from experimental technology to essential enterprise capability. Through over 7 decades of innovation, spanning symbolic reasoning, statistical learning, deep neural networks, and generative AI, artificial intelligence has evolved from a theoretical aspiration into a transformative force reshaping virtually every sector. As AI systems become more capable, responsible development and governance will be paramount.